insights just like we did last time. So Billy from API 3 will be exploring sort of part two with him with respect to what he has to teach us. I think, Billy, also, before we begin your session, it would be cool to maybe recap for the audience what we did last time. But before we start that, just for those who don't know, this is Sonic Builders Hour. We do this whichever Fridays are available for both myself and the guests that are coming. And the idea is to spotlight infrastructure partners, builders on Sonic, and to give everybody sort of a chance to show off their products, and also to promote interoperability between different products in our ecosystem, different builders in our ecosystem, different infra partners, etc. So that's what this is for. And so this week we have Billy again. So this is his second time on the show, and he's going to be continuing from where we left off with API 3's presentation on how to Oracle extractable value and some other interesting concepts. So definitely tune in. I think it was super interesting for me last time just to listen in and sort of learn everything that Billy had to share. But yeah, Billy, do you want to start with a quick recap, and then whatever you want to share before we begin?
Absolutely. Yes. Hi. Again, I want to apologize. My camera just decided to go kaput like literally minutes before the workshop. So you get to deal with my PFP today. But yeah, just to recap, it is a multiple series type of workshop. I guess my biggest critique as a aspiring dev when I started learning was people only talked about their products, but not how to use stuff around the product. So I wanted to create a series that one was a niche around DeFi. You hear all these things about liquidations when the price goes up and price goes down, like billions of dollars liquidations. And I was like, well, how do I get a part of that? Right. And so, through space, I got connected with API 3 and learned what they built and how that works. And then I was like, cool, how come nobody else knows about this? Right. So here we are as a DevRel now and explaining certain things. And I'm like, okay, what do people really want to learn? How do things work? People like, oh, how do I borrow land? How do I leverage? How do people LP? And like make money with the money they have right now. So I've created this kind of like starter searcher series that kind of takes you from A to Z to become a very basic searcher. So that way, if you do stuff on Sonic, and you're seeing opportunities with these new dApps coming up, and you see liquidity and you see volume moving, like yesterday, we saw tons of volume moving left and right, the price is dropping and things. How do I make money off that, right? Where's the opportunity for me instead of just buying and holding as a dev, a developer? Like, how can we make additional income on these kind of situations? So hopefully this is a start of series that will get you there, right? So the first workshop that we did last time was just an introduction to API 3 oracles, like why we need oracles for smart contracts, external prices, and then we went past that, like using adapters. Let's say you found this great repo and you want to deploy it on Sonic, but Chainlink doesn't have the price feed. Well, what API 3 does, right? So that way you just use an adapter or you use some kind of interface without having to refactor your code. You happen that all the time. Maybe you're doing a hackathon and you want to build on Sonic Testnet or something, and you don't want to refactor all that code. You want to use that idea and build off that idea like a Lego block. So we showed you how to do that with a very, very basic example of how each Oracle works and how they can work interactively. Today, we're going to be talking about OEV. The one thing that sets this Oracle apart from most all other Oracles, right? Like every Oracle, at the end of the day, they give you a price feed. It doesn't matter if you are reading what's the price of ETH on CoinGecko or CoinMarketCap or any other, API service, right? They all do the same thing. But what if when you read it, it actually made money for you? So now it gets interesting, right? So I'm going to go ahead and share my screen, do a little slideshow, kind of like recap of what we've been doing. And then we'll get into the nitty gritty of like how this works and why this works. And then if there's any questions, stop me at any time. I can chew gum and walk at the same time. So we'll just talk away.
Sick. That's awesome. I'll get off camera because my team is telling me I look like I'm in prison. So I'll pop
Okay.
in whenever there's a question, and I'll stop you. But yeah, for now, take it away. This sounds super interesting.
For sure. Awesome. So API 3, just in case, oracles that pay you. And today you're going to understand what that actually means. I am your development support. Usually I'm on camera. That's what I look like. If you are into technical talk or just regular, random posting with funnies, I'm your guy. You can also reach me on Telegram directly at Billy Jitsu on there. So just in case, I'll leave this up for a second for people that maybe were watching it later. And so again, just to recap, the first workshop was the fundamentals of API 3, how to use price feeds, going through the marketplace, picking a price feed, switching it in your smart contract. It took about 7 minutes to do it. It's really, really short, like 14 lines of code total. So really easy to do. And then talking about adapters and, how to get that all configured for any network that you want to use. Second workshop, which is the focus of today, is Oracle extractable value. Understanding how push and pull oracles work. You might hear that from time to time, and it doesn't really make sense of like why they're different. Introduction into the OEV network, why we went this way, and then we're going to learn how to update an actual API 3 price feed on mainnet. So like this doesn't work on testnets. This is mainnet, so I am using real money to make this happen. And we're going to do a bid, and we're going to win the bid, and we're going to understand why we even do that. Third workshop, which gets everybody kind of excited, is we're actually going to deploy Aave. We're going to learn how to deploy it with the CLI tool that we've built. You're going to basically have a borrow lending DApp that you can adjust and use for your own needs, whether it's a hackathon, whether you want to fork it and then clean it up for production. Totally up to you. And then you're going to learn the basics of like the nomenclature of like, collateral and debt, and understanding how liquidations work. We're going to use this very tool to perform all our liquidations, all our OEV liquidations, and our flash loans here, which was the intro into the fourth workshop, is flash loans, right? We've learned how to make liquidations. We know how to make 5-10% when the prices go up and down and there's a position to liquidate, but we don't have millions of dollars in our wallet just ready to do liquidations at any given time. So we borrow it for one block amount. And so we borrow it from our borrow lending DApp, borrow the $1 million, pay back the loan, pay, and then keep the whatever percentage we had as profit, right? So that is the true potential of what OEV can do, right? And that's what really makes blockchain different than any other kind of like industry, right? Like if you go to TradFi, there is no way we can get a flash loan, get borrowed $12 million for 12 seconds, right? And that's what makes this space so cool. So today is the focus is we're going to actually update a price feed using the OEV network. So workshop breakdowns, the key learning points that I want you to walk away with is, where is the value going when there's a liquidation, right? Like we hear about liquidations all the time. Who's getting that money, right? Like where is that money going? And then the flow of like what the current meta is right now. And then we're going to update a price feed with OEV. Kind of the whole point of the workshop is we're going to actually bid on the OEV network, and then we're going to actually update a price feed in a smart contract. So what is Oracle extractable value, right? Like it's a very complicated, very mouthful of work, right? We've all heard of MEV, maximal extractable value. Well, Oracle obviously has to do with oracles, right? So, prices change on every asset anywhere. If you go to Coinbase, Binance, or anything, and you look at a chart like TradingView, you see like every second it's shifting up and down, and like pennies or dollars, depending if it's a Bitcoin or some kind of meme token. If we were to do that on chain, any Oracle would run out of money like within a couple of weeks, right? Because every transaction on chain costs gas, no matter how much it is. It's eventually going to dry up the funds, right? So consensus has us having like updates at certain thresholds, right? So imagine doing this on mainnet, right? If the price changes from $2,000 to $2,005, does that really make a difference for a lot of people? Maybe yay, maybe no. But what we realize is about 1% is pretty much the standard of price changes. So only if the price value of something has changed 1%, should it be reflected on chain, right? And so when we do that, then we have a certain threshold or deviation of price. So when we do certain things like borrow lending, basically math and all that statistics, and you see all these groups that do all these analyzations, 1%, 0.5% is a pretty good amount to change prices on chain. What Oracle extractable value does is allows anyone to place a bid to update that Oracle before it hits that 1% change or 0.5% on there. So let's get into the details on that. What is the extractable value part in there, right? Let's take the whole idea of this, right? We have this position on Aave at ETH valued at $2,012, right? Right. So for simplicity, right now ETH is worth $2,000 with a 1% price deviation. So what happens is it changes at $20, right? So it either updates the Oracle at $2,020 or at 1980, right? Because that's $20 either way, depending on where the market's going. So on chain, we're looking on CoinGecko and we see ETH is on a climb, right? It is 2000, $2,005, $2,012, $2,019, right? I can liquidate this at 2012, right? But I cannot actually see that on chain until ETH gets to $2,020. So on chain, it is still $2,000 because it has not met the 1% deviation price change, right? So I'm salivating because this is a $1 billion liquidation and I want it, right? But I cannot do it till it hits 2020. And sometimes you see on social media like, oh, this $1 million position is going to happen when it hits this price, but it never actually does. And that's the way the oracles work. But at the point ETH hits 2020, the price updates and it becomes an MEV battle, right? Of bribery payments because I want it, you want it, everybody else watching this video wants it, right? That's 5% off of millions of dollars. That's a lot of change on there. So whoever is the first person to be in that transaction is the winner, right? So we have to like bribe a validator or something like that. So most of the profit actually goes to the validator, right? Because I have to pay the validator the MEV price fees, and then I get to do the liquidation, and then I get whatever's left over once I do the swaps and all the slippage and everything. But the validator kind of got most of it because I wanted to bribe that validator first so I can be on first on the block, and then I win, right? So this is just so you can visually see it on here, right? We have our price Oracle update at $2,000. The Oracle only gets updated on chain when it goes in a $20 deviation because 1% is $20. So 1980 would be when the Oracle gets updated, and 2020. So even though I can liquidate this at $2,012, I can liquidate it when I've done the math. I cannot liquidate it until it touches 2020. So like right now I'm current value. So like everybody's, holding their breath, waiting. The bots are ready to go on deck. But until 2020 hits and the transaction happens and it happens on chain, I can't do anything. So
Billy, could
go
you
ahead.
just could you clarify the difference between the 2012 number and 2020 number just once more?
Correct. So if ETH hits a value of 2012, there is a position, maybe somebody shorted ETH right now, right? And they deposit stables and then they borrowed ETH. And then if it hits this, I can liquidate them because they become in an unhealthy position, right? And so on chain, it shows $2,000. Off chain, I can see that, it is higher than that. It's currently $2,019 off chain. But because it has not met the 1% deviation change in price, it on chain, when I look, the value is still $2,000. So I can't do anything at that current time
Okay.
to perform the liquidation. Yeah.
Okay. So the deviation has to occur to trigger the update, and the update then will allow you to liquidate because then it's exceeding the threshold of like 2012.
Yes, exactly.
Okay,
So now
got
anybody that's liquidable within this position can all get liquidated. So even if there was like a million positions right here and there was 2019, I
it.
could not touch it.
Got it. So liquidations are sort of done in batches then.
In a sense, yes.
Okay.
Until OEV, basically. So just so you can see the liquidations on lending protocol, right? First thing that has to happen on a liquidation is the Oracle has to update first. Then the health factor changes, right? So the ETH price changes on chain, then the health factor changes. All the searchers then see all the liquidable positions. The competition for the block stays happens, and then the user gets liquidated, right? Profits between the searcher and validators happen, right? So this has to happen in order in this because the Oracle has to update first before any of this could even happen. So this is what the current MEV flow is, right? Most of us kind of know what it is in a sense, but this is a general flow, right? So I found the opportunity, and so I have to pay a large fee to the validator, not the sequence, the validator, in order to be first, right? Because they can reorder the transactions. So if all of us are in line to do it, I'm willing to pay an additional ETH to the validator to be positioned first, right? And so they keep the gas fees and they put the transaction to perform the liquidation. I liquidate, right? The borrow lending DApp has to pay me an extra 5% for a bonus in order for me to keep the platform healthy. That's just how borrow lending works, sometimes between 5 to 10%. So the borrow lending DApp has lost 5% of TVL that generates them fees. The unhealthy position gets paid off. I get my profit minus my initial gas fee, right? So validator aftermath is 1%, I'm sorry, 1 ETH profit. Validator, so that's mistyped right here. Me as a searcher gets liquidation amounts minus what I ate. And then the borrow lending DApp, they get nothing. They get nothing out of this transaction. They stay healthy and they lose 5% of TVL. And that's one major metric that a lot of people base borrow lending dApps on, is how much TVL are they actually holding, right? So every time there's a liquidation, they're losing 5% TVL every time. So how OEV aims to help with this issue, right? Searchers can bid to update a price feed through the OEV network, right? And we'll cover that in a little bit. If they win the bid, that allows them to update the price feed at any given time, right? So they don't have to wait for the 2020. They don't have to wait for the 2019. They can do it at the current value that it is right now on there. And that's the very important thing. That signature is bulked with the liquidation transaction. So we use like a multi-call contract. So we can do multiple transactions at the same time. We do it atomically. So if I update the Oracle and then I send another transaction to liquidate, there's going to be another searcher that's going, hey, thanks for paying for the update. I'll take it from here, right? So we want to batch those transactions in a single call. So then we update the price feed and liquidate at the same time. Right? And so then the value, this is the key point here, the value is split back to the dApp and the searcher instead of the validator, because I'm not bribing them to be first. I'm bidding to update the Oracle. So we redirected where that value is going. So here's the flow. It looks a little bit crazier, but here's what happens here. I'm the searcher. I see an opportunity. So first thing I have to do is I have to make sure I deposit a little bit of money on the OEV network, right? And I bid. I say, hey, I want to bid point one ETH to do this liquidation using the same example, right? On the OEV network, I only need 10% of the value of what I want to bid. We don't want your value on the OEV network. We want your value on the chain that you're doing, your executions on, right? So I'm listening to the OEV network. I win the bid. They give me a special signature that says, oh, only you can update this Oracle, right? Otherwise, it's kind of pointless. So I win this signature. Now I send this, transaction out through a multi-call bundle. We're going to do it through the smart contract, in which the bid amount that I bid, so I want to bid 1 ETH, gets sent to the API 3 server. And then I send out to do the price feed update and liquidation transaction in this single transaction. Sequencer does it. It doesn't matter where I sit in the block, because remember, in order for me to do the liquidation, the price has to update first, and then I can do everything else, right? But I control when that happens. So in the sequencer, it happens. So the price feed gets updated and the liquidation is performed, and then I keep the profit, right? And then everything else happens. So here's the difference, right? The searcher profits minus the bid amount, so the minus the 1 ETH. The API 3 server gets the bid amount balance that will be distributed later. And the borrow lending dApp loses 5% TVL, but that bid amount that we just did, the API server, 80% of that goes back to the dApp. So they actually get a return on that versus getting zero. So here is kind of like a flow of like what's really happening using that same example, right? The price was updated at $2,000. The liquidation value is at 2012. As soon as it hits 2012, I bid and say, hey, I see that the value is 2012 on ETH. I would like to bid on that to make sure that I can have the right to update it right now instead of waiting until 2020, if it ever gets there. We don't know if it'll get there or not. So if I win that bid, I can then do a transaction that will update the Oracle to the most exact price. So I'm pulling the price down and making sure that it happens updating on chain. And that's the only difference, right? With OEV, it becomes more accurate because it only updates the price feed when it matters, right? Otherwise, we're just pushing updates. It pushes at 2000, and then the next price change, it'll push at 2020 or 1980. So that's what a push Oracle does. It's just pushing updates on the deviation automatically. No one calls that transaction to make it happen. API 3 or any other Oracle that's push will push it on chain constantly. And then people can read that transaction value and then, put it on their borrow lending dApp or perp or whatever they want. But with the pull, we are actually pulling the latest price and then bringing that data on chain with another transaction. So if no one pulls it, it's just business as usual. But when there's something that actually has monetary value that incentivizes me to pull it, I'm going to pull that price down and make that price feed a bit more accurate. Does it make sense?
Makes sense to me.
You went on off and out. You went on and off real quick.
Oh, did you hear? You couldn't hear what I said?
No, I couldn't hear.
Oh, I said, yeah, it makes sense to me.
Okay.
No questions
Okay.
for me so far. That's
Cool.
super clear. Yeah.
Cool. So let's talk about how this bidding works, right? So there is an auction system. It happens every 30 seconds for the Oracle. So every auction is in a set timestamp. Like it doesn't happen every 30 seconds for ETH, and they're all kind of like staggered a little bit depending on when the feed was launched, but they all start on their 30-second range. So for the first 30 seconds, if that ever existed, we have 25 seconds to bid on there. And then the last 5 seconds are the auction results. So let's say I'm the only one that bids on auction one, and then 5 seconds later I get the auction results. I win signature gets sent to me. For the next 30 seconds, it is my opportunity to update the price and perform my liquidations. At the same time that I'm doing these liquidations, there is another auction happening at the same time for the next 30 seconds. So in a black swan event or an event like yesterday, I still have to look at the OEV numbers from yesterday, but when we're dumping hard, right, whether politicians are fighting or some kind of bad news, China China
Yeah.
bans Bitcoin, right? There is multiple opportunities to do liquidation. So like, let's say we're dumping 10%, 15%, and there's more opportunities to liquidate. I have 30 seconds to go crazy. So I can keep updating indefinitely if it makes financial sense for me to do so. If it does not, we just wait on the deviations. But this also covers black swan events because therefore I can just keep updating. And then if the second auction winner wins, they take over from there, and so on and so on as auctions. And if nobody bids, then it's just business as usual. The deviation will happen when the deviation happens because there is no financial incentive. But
So
every 30 seconds, there's a pulse.
it's interesting that you sort of using economic incentives to keep data accurate, kind of the
Yes.
way like the premise of prediction markets as well, right?
Yep.
It's quite
Exactly.
interesting.
Yeah.
Yeah, cool.
So what has OEV captured so far? Just to, so like this is a kind of like a new concept. We dropped it in 2024, not 2014. 2024 was when we first launched it. They wrote the white paper about, I want to say 2 years ago, with the idea of like how this works. And February 2nd, 3rd, depending on where you were in the time zone, was probably the biggest liquidation event in crypto history, right? Billions of dollars actually lost on here. And so it was all theory until it actually went live, right? Everybody has amazing theories and amazing numbers of what happens if something happens, but we don't really actually know until it's real, right? And so in the very early stages of our launch, we actually had again the biggest stress test that you could ever have, and it worked perfectly. Right. So compound on mantle is $2.6 million liquidated from a single price feed of USDC. We return $150,000 value straight to them just because they used their Oracle, right? That's it. Yay Finance on Say, 370 liquidated, 42,000 returned. Landell on Mantle, 190K liquidated, 16,000 in value returned. And these numbers may not seem magical according to what was liquidated, but then when you look at how much revenue gets generated, it's crazy, right? So Compound yearly earns about $9 million through borrows, right? And then 5 weeks into 2025, they paid out $5.3 million in liquidation incentives. Remember that 5% returns or 10% returns to keep the platform healthy. So in the first few weeks, they already paid out half of their profit, right? And so we were able to return $150,000 back when any other Oracle they used would have got them exactly zero. So that's huge, right? So borrow lending dApps are like, hey, I like it. But these are things that happen during a crazy stress test in the early days of like the biggest liquidation event ever. So what do we do to build a searcher bot to take advantage of this situation, right? We want to become searchers. We want to be part of these liquidations, right? I want that 5-10% of those large liquidation amounts. So this is what we're going to do. You can use almost any scripting language you want, right? That has an ETH library, right? So Ether's GS, VM, Python, Rust, whatever has an Ether's library, you can use it. Our example for today is using Ethers.js and JavaScript. Very basic. You'll need to deploy your own multi-call contract and liquidation contract to call. Don't worry, I got you in a package. And you don't really need to modify anything in the contract. I built it. It's ready to go, ready for you to deploy. And we're just going to go through that flow. Right. So let's just understand like what the liquidation flow is, bird's eye view, and then we'll get into it like on the flow. So we as a searcher, we're looking for opportunities, right? We're using indexers, we're doing stuff off chain, right? I'm looking at all the contracts that have borrow lending dApps and seeing who has degen positions, right? How close are they to being liquidated? So I'm calculating the price of liquidation. If E hits this price, I know I can liquidate these people. If E hits this price, I know I can liquidate that person, right? So I have all these locally set. Once I know these prices, I'm going to have my bids ready to go. I want to place bids on the auction house contracts on the OEV network, right? I'll say, all right, if he hits 2012, I want to place a bid for this, right? And so let's say I win, I receive the winning auction. And so now I'm going to combine my price update signature with my liquidation transaction, kind of like how we explained before. I call on my smart contract, price feed updates, liquidations occur all on the same call. Really nice for a simple liquidation flow, right? What's really happening on my local computer, right? Let's get into a little bit deeper, right? That was a little small segment. What's happening is I'm gathering all the addresses that I've ever borrowed, right? On the layer 2 network. Let's say we're doing like Sonic, right? I'm getting all the addresses that have ever done so. Now I'm storing that on a local database, right? Maybe it's an SQL database, maybe some kind of sequence database. And then I'm now monitoring all the health factors of all the users on that network. So I'm doing RPC calls. I'm using kind of tools out there that helps me does it, right? And so I'm storing all my opportunities in this local list. Again, I'm calculating my liquidation price. And so once I have that, I'm going to bid doing some magic on the OEV network. I get my bid. I combine that transaction on there. I call my multi-call contract. I update the proxy feed and I perform the liquidation, right? So it's getting a little bit more detailed about the flow of this, right? We have to like do a lot of communication back and forth in order to make this happen. So what's happening with the OEV flow is, again, doing the same thing, gathering my users, storing my address, storing these opportunities, calculating my liquidation price. What's happening on the OEV network is I'm setting up my bid conditions. I place my bid. I'm listening for the bid. I receive that winning auction or tell me, hey, you didn't make it this time, someone outbid you. And then I kind of do the same thing over and over again. I update, perform the liquidation, and then I answer back saying, hey, I did behave. I updated the price feed. I didn't just bid to block people updating the price feed so I don't get slashed, right? So I report that I updated the Oracle and I show proof with that transaction. So the details about this thing here is that on the OEV network, you only need to deposit 10% of what you actually are willing to bid in the auction. So if I want to bid 1 ETH on something, I only need 0.1 ETH in the auction house contract as a stake, right? Because if I bid without doing any performances and I'm trying to be nefarious, I'm going to get slashed, right? That's the only incentive that keeps people honest is, you get slashed, right? If I don't pay the fee on the OEV network, you don't pay the fee on the OEV network, you pay it on the chain that you are updating the price feed on, right? So I only bid on the OEV network, but when it comes time to do all my updates and pay the bid, I do that on Sonic Chain, right? The fee value then gets passed to the API 3 server contract in the price feed update transaction. So I'm not paying the Oracle, I'm paying the API 3 server that bid. So that way the API 3 server can then distribute it back to the dApp so they can get their, the money for getting their Oracle updated. The dApp can then withdraw their value from the contract and then use the value they can see fit, right? So this is the new thing that is generating value for dApps, right? So it is very competitive to get borrow lending dApps, right? APYs are almost identical across all kind of borrow lending dApps, right? USDC is kind of like what 5% returns right now, no matter whether you're using Morpho, Compound, Venus, Aave. It doesn't matter. They're almost exactly the same because that's just what it is, right? So how do you set yourself apart from all these winners already, right? Everybody has these brand names. They know Aave exists, Compound exists, Morpho exists. How do you set yourself apart, right? Well, if you have the ability to generate new revenue, you can come up with new reward systems, right? You can have better APYs to deposit. You could lower the liquidation penalties for someone that gets liquidated, right? They get liquidated for, $5,000. Well, here's $2,000 back. So it hurts less, right? So depending on what you want to do with that OEV revenue, it's totally up to you how you want to create it. Do you want to fund public goods? Fund public goods, right? Like it's your money. You could keep it or you can do stuff to incentivize, right? That's totally up to you. But now there's this newfound income just by switching oracles. So a little bit more details on that. In your bid details on the OEV network, the address of the transaction center is the part of the winning signature, right? So when you send out a signature and it's all public, like everything is on the public blockchain. We do everything public on here. So there are other auctions that do everything private, but then you can't say who really won, right? So everything is all done pretty much on chain. And so if that address is not calling the price feed update, it will fail. So that way you don't get front run, right? So everything is public, but they all basically get whitelisted at that one time for that one winning bid. So you can not get front run by somebody other, some other searcher reading it from the mempool, right? So the smart contract allows us to combine the transactions in a single transaction call. So price feed will then get updated, and then we do the liquidation calls, right? We don't do our liquidation calls first because the price hasn't updated. We make sure to update the price feed first in the smart contract and then do all our logic after that. If you call the update price feed without a multi-call, your next transaction can be front run, right? So like if I update the price, every other searcher on there that sees that update price transaction is going to wreck me, right? So you want to make sure you do things atomically. So enough talk. Here's a link to the example. This is the GitHub repo in the private chat. I'm going to give you the link to share on the chat, but let me go ahead and pop that in here in the private chat. Boom. And that way it can be shared out. I'm just going to leave this just for a second, and then we're going to get into the actual code script here.
Nice, thanks.
Boom.
I'm sharing it under the stream post, so if anybody wants to follow along, please feel free.
And for those that are not Ethers.js fans, or I want to do things in TypeScript, I hear you people. So I actually redid the whole thing in VM as well. So if you wanted to use TypeScript and VM, I'm going to throw that on there for you too. I listen to the people. I'm for the people here. So that's pretty much what that's going to be as well. So let's look at this this code here. The ENV example can be intimidating and it's scary, but just note that we are going to use this for the entire series. So a lot of this stuff is not going to be important for us at this current time. We're going to be using these later, and we'll slowly fill this out over time. But for today, we're only going to be worried about these three constants on the .env. The OEV network is pretty standard, and your target network, right? We're going to be updating a price feed on Sonic chain. So here's my RPC for Sonic, right? And then I don't use a private key. I use a mnemonic for this case, because what we're going to do in the future is we're going to create a position with one wallet, and then we're going to liquidate with another wallet. And if we want to add a third wallet, we could. So instead of having like 15 private keys for different scenarios, I just use one mnemonic and I generate wallets based on the mnemonic, right? I can do 15 wallets, 1,000 wallets, whatever I need to do. So I'm just using a mnemonic for that. So let's look at the smart contracts. It's only one of stuff, so don't worry too much about it. Again, like this is going to be for the future, but if you are someone that likes to peek ahead, go for it. So OEV auction house, it is just an import. We just want the ABIs from it. So all we did was create this nice import. So it automatically pulls in the API. This does our deposits. This does our bids. And if you wanted to see that on here, there's a link on this, but you can basically look at the smart contract OEV extensions and see what's available in the smart contract. But just know that you can bid, withdraw, deposit. It's just a simple function. We don't want you to like get caught up in the sauce for this. We just want you to drive, right? I don't want you to rebuild the engine for this Mercedes. Just push go and stop, right? So don't bother yourself too much with it. Just know that that's all that's in there. The most important one is our OEV feed updater, right? This is the one we're going to deploy today. That's going to help us do our update. And it looks intimidating, but when you really look at it, it's only two functions here. And that's it. Two functions. So we have these things for the auction house and the OEV bid and this ownable right here. And so the ownable is important because this is where it holds the money. When we do our liquidations, when it does all the smart contract calls and we do all our logic, the money's going to be sitting in here. And if it doesn't have some kind of ownable system, another searcher can just steal the money from our contract. So we paid all the fees, paid all this, did all the hard work, and the money sitting there, and then someone says, yoink, thank you. So we just put some ownable on there to make sure that we're good. And we are going to do something called a DApp ID. When we do liquidations, we do it by DApp ID. So like ETH USD on chain is generic, but if let's say I want to call it Vicuna, but it's not anymore. It's Stability DAO on Sonic. Stability has their own DApp ID, right? So I know I want to update the oracles for Stability. So I'm going to specifically say it for that specific DApp. This OEV extension stuff is just basically imports that create the interfaces for us on here. And these are just like basically callback stuff. So you don't really change any of this stuff. These are all kind of built-in cookie cutters. So you don't have to like do any modifications to this contract. I just kind of want you to know that those are there, and you don't really need to modify it. You just use them as like, a framework on here. And this is what happens when we deploy our contract. This contract specifically is for this DApp ID. Again, we can make it generic if we want to, but we want to do it for our one DApp that we want to have. And then where is the server extension for that chain on there? So where's the API 3 server on Sonic network? Where's the API 3 server on any other network, right? We want to know the address. Well, we have a tool built into that already that automatically generates for you. We use predetermined contracts, so they're mostly always the same at every time. So that's just our setup of our contract when we deploy it. And then it's kind of just sitting there waiting to be used, right? So this is the way it flows. We're going to call this function pay bid and update feed from our script when we have a time. All it's going to do is we're going to send the parameters. Hey, I want to update this price feed. I want to do this and all this fancy logic. And this is how much I'm willing to bid. All it's going to do is say, okay, it's going to decode all that information. It's going to have the DApp ID that we want, the bid amount that we want to do. What is the auction time that we're doing it? Remember, it's every 30 seconds. So making sure that we had it in this certain bid amount. If we bid, or if we try to do this after the 30 seconds that we're allowed, it's going to fail, right? What is the winning signature that we got? If we won, it checks the signature, and then it's going to encode all this callback data. What do I mean about callback data? So in order for things to happen atomically, happens between two contracts, right? Like flash loans, and we'll cover that in a little bit, like in later workshops. But one contract will call another contract, and then that contract will call back to the same contract, kind of like a back and forth conversation. And so it forces contracts to be in sync, and everything has their check and balances. Otherwise, it'll revert the whole thing, right? So like flash loans are theoretically kind of safe, because if you borrow money and then you put in your contract, but you can't pay back the loan, it'll never borrow in the first place. It'll just revert. Well, that's kind of what callbacks are. We are making sure we pay our OEV bid, but we haven't actually sent a payment yet, right? But if we look at the API 3 server, and if we go into this pay OEV bid that we're calling from this contract, right, it's going through all the checks and balances, and then it's calling another on OEV bid payment, right? It's calling another function from my contract that I just deployed, and that's on OEV payment here. So all we're doing is sending all the bids information, saying, hey, this is what I want to do. Send it to the API 3 server contract, and it's saying, okay, cool. Let me go ahead and go through all the logic here, checks and balances. All right, cool. Everything looks good. Let me call your contract to make sure that this all works. And so this is basically calling back from that contract saying, hey, how much are we willing to bid? And what's all our details, right? It's all the data that we have, like, liquidation logic, all this logic that we have is going to get passed on here. So we're making sure that it's, right from the server. Only the server can call this, and it has all the data that's going to decode, on there, because we have to, we can't say, hey, just do things in JavaScript where we have like this array of stuff. It all has to be encoded into a single data call in bytes. And so here is the magic right here, right? It is actually updating the data feed. This is the one thing that we do call right here. It updates the data feed first. Remember, we want to update that data feed. So that's happening first. So it's doing it for the specific DApp ID, and then it's making sure that I have that signature from the auction house that I won. I'm allowed to do this. So cool, we're good. And then it'll actually pay the bid amount to the API 3 server of whatever that bid amount was, right? And this is being used because I'm not calling it right now, because it's just an example that we're using here. And then it's going to say, hey, we did a callback success. Everything looks good. In between this right here, this OEV bid payment, after we update all this, this is where the magic happens, where we do all our logic, liquidations, flash loans, everything in under the sun, right? But this is a lot of information to swallow at one time. So all we're going to do is just update the Oracle feed, right? Once we can get the update Oracle feed, let's start adding a little bit more complications to it. But right now it is, it's a lot. It's a lot to swallow, to be honest. So, but at the end of the day, it's just two functions, right? You send your parameters. Hey, send the parameters. It's going to send it to the contract to validate. All the validation looks good. I said, all right, let's move it. Let's move forward. Let's update the price feed. Once I update the price feed, I do whatever logic I want to do, and we're cool. And that's it for the smart contract. That's our callback multi-call type of information where we stuff as much as we can in the contract. Our only limitation is the gas, right? The gas of whatever block we're using on whatever chain. So if I have 40 million gas available to me, I can go crazy, do swaps, do everything, multiple flash loans and whatnot, right? So that is it in the smart contract. These two we do not look at until later in the workshop series. So I'm going to minimize that, and let's go into the scripts. And I'm going to go ahead and get rid of this because as a good DevRel, I made sure everything worked before I actually went live. But all right, listen to the scripts here. So there's only a few things that we need to do here. And this one is deposit collateral. And actually, I'm going to make this a little bit bigger so you guys can see that. All we're going to do is once we bridge to the OEV network, we want to deposit our collateral. If we want to bid anything on the OEV network, we have to deposit collateral. So that way, if we're nefarious, we get slashed, right? And it's nothing special on here. We have this API 3 contracts import. So that way you don't have to go looking up for addresses. We have all the addresses registered on this database. So you just pull the contracts. And so if you're looking for this DAP ID, or if you're looking for this chain ID, you have it. And then this is just the ethers import and .env for all our private stuff. So nothing out of the ordinary. Here, we're just building our objects. And you see that we have deployment addresses under API 3 contracts. OEV network is 4913. So you don't have to change any of this. For the deposit amount, I'm just depositing a little bit of ETH just for the demo. So I'm just doing really, really tiny amount of ETH on there. And I just call it a deposit function on the auction house, and it lets us know that we deposited. So I've already went ahead and bridged over to the OEV network. It takes a few minutes, right? And it's on the link on the repo. But you bridge from Ethereum to the OEV network, whatever amount you need. I think we've all kind of used bridges before, swatch from one location to another. And, it takes 10, 15 minutes to verify in all the blocks, and then you're up and running. Right. So I have a little bit on there. So I'm going to go ahead and deposit a little bit more ETH on there. So I'm going to go yarn. And it's literally the name of the script. We have all these yarn packages available for you here. So all these are all ready to go. And it's yarn deposit collateral. And it'll deposit my little amount of ETH on there. There we go. It deposited 0.0001 ETH to the auction house, and there's my transaction house. So I'm looking cool. I'm ready to bid this amount of ETH available to me. So that's all we need to do there. And so now we want to look at deploying our OEV feed updater. That is this OEV feed updater smart contract. We want to deploy this, right? So all it's going to do is the deployment script. It's going to deploy it to our chain of choice, which now I have it on Sonic Network. Right, and it's just a deployment script. So that's all it is. It compiles this, deploys it, and then saves it to a local location. So let's go ahead and deploy our contract. That's going to update and be our multi-call for that. So yarn deploy OEV feed updater. Did I spell that right? Yes. We're going to find out if I spelled it right anyway. And there we go. OEV feed updater has been deployed to this contract address. If you look here, there is a deployments JSON file that just saves it. So when you start deploying a bunch of stuff and it's hard to maintain, it's just going to a JSON file that it'll reference at, right? So we'll save that for a little bit on there. And so now let's go into this bread and butter, this whole thing of what you will be doing mechanically is this submit, bid, and update. And so I'm submitting my bid, right? And then if I win the bid, I update the Oracle. So that's all it's going. If you want to peek ahead, there's the submit bid liquidate, right? And then the submit bid flash loan liquidate. If you kind of been following along with the workshop template, you'll see exactly where this is heading, right? But for today, we're going to go ahead and do the submit bid and update. And this is going to look intimidating. It looks overwhelming, but it's not bad once we actually get there. So there's a few things that we have to do in our script in order for this thing to even work, and a few setups, right? So we have this ethers library that we're going to use. We have our API 3 contracts for all the contracts we want to use. We have this thing called fetch OEV signed data, which I'll explain in a little bit. We're going to reference our deployments, right? I have this deployment file, so we don't have to keep updating .envs for every time we change stuff, and then the .env. Right? So let's go through this really quickly. We know that the OEV auction length is 30 seconds. We know that every 30 seconds. We know that the bidding phase is 25 seconds. and then we have to wait for the last 5 seconds in order for this to work, right? So we have this little buffer for us to listen at. The OEV of auctions is version 1, so we haven't changed that. So whenever there's a new version, we'll update all that, but it's just version 1. And for today's experiments, we're using DAP ID 1. What is DAP ID 1? That is the actual generic one. So if I go, oops, not that. I'm going to go to Market API 3, Market. There we go. And we're going to go over to Sonic, and we're going to go look at exactly what that means. So if I do ETHUSD here, see the skip OEV rewards? This is the generic public RPC. Anybody can use this, right? Anybody can use this Oracle. It's submitted on chain. Anybody can use it, but they will not earn OEV rewards. This is what DAP ID 1. This is the generic Oracle for every chain. And so you could use it, but I don't recommend it because you will not get paid if someone updates this Oracle. When you want to earn OEV rewards, that's where you can say, okay, as a searcher, I'm going to look up, I think it's stability, stability down Sonic. And this is the Oracle that I want to update if I want to update stability's ETHUSD one, right? And then if I update this Oracle and I bid, stability gets paid. So that's the only difference. But for our demo, we're doing skip OEV rewards. We're going to see this update, and we're going to update this specific price feed. Is my browser like stuck? And that's why DAP ID 1 is the one that's going to be used. So we're going to update this price feed at this current moment. So again, for every DAP, you want to make sure that you have the DAP ID. So we're just using DAP ID 1. Again, if this is confusing, stop me at any time. I'll definitely explain more in detail. All this does. Oh, go ahead.
I was just going to say communal proxies.
Yeah, basically, yeah. So these are all just creating objects, right? We all know how to set up our objects for our RPC URLs, for our contracts, and building my wallets based off my mnemonic from the phrases. And this is how much I want to bid, right? The bid amount is exactly what I want to bid. I can do that on the .env, so I'm just hard coding it here. I want to bid 0.0001 S. So that is, I'm bidding the value amount of the chain that I'm bidding on, right? If I'm doing something on mainnet, I'm bidding in ETH. If I'm doing something on Sonic, I'm bidding in S, right? So I'm basically letting people know that this is my auction. I want to bid 0.001 with this, like, I don't know, like a thousandth of a penny, right? No, there's nothing of value for me to liquidate at this current time. We missed the opportunity yesterday. Now it's a little bit more stable. So I'm pretty sure I'm going to win this bid with a small bid, right? If there's competition like yesterday, I'm not going to win any bids with this kind of low value, right? So, that just for demo purposes. And I want to update the DAPI name. I want to update the ETHUSD, right? I want to update ETHUSD. This is the one I want to update right here. So that's what I have here. It's in basically English language. And so I have these functions on here that we're going to kind of go through. A lot of this is cookie cutter, right? We don't have to change a lot of this on here. So it's just, looks scary, but it's just cookie cutter stuff. So what we need to do is determine when is our cutoff time, right? When is the 30 seconds that I can bid? When is the next 30 seconds? And do I fall in that range? And this is just math that does that, right? It's going to check and encode a few things to say, hey, am I in the right 30 seconds or not? Do I have the right time to bid, or is someone getting awarded a bid? And that's all it's going to let us know. It's like, hey, you made it within this 30 seconds, or you have to wait the next 30 seconds in order to bid. And that's all this is it determining when the signed data is time to be cut off, right? Bidding time. The get bid topic is all just encoding stuff right here. It's going to do this Solidity packed Ketchak on there. That's just going to look at all our OEV auction version. It's going to check the DAP ID, what's the auction length, and then when's the cutoff time, right? That we calculated from this determined time cutoff time. We're going to find that value on here. So all it's doing is doing some encoding for that certain 30-second time range, right? So it's like, all right, this is the 30-second auction for this bid topic. We're going to get the bid details. We're letting the auctioneer know this is the address that we are going to update from, right? We're not updating from our EOA wallet, right? We don't really do liquidations. We don't do anything from an EOA. You'll see all these professional liquidations happen from a smart contract because you can do multiple things to it, right? And so we're letting you know, hey, this is our smart contract that's going to be doing the update. So make sure to, when we bid, we're going to go ahead and do a bid and code this address on here too. We do hexify and randomize it because every auction bid should be different. So in order to make sure that each unique bid is, unique, we randomize it, right? So that's all it does. It's just some encoding. So you don't change any of these whatsoever. It's just as is. Here, we're actually going to go ahead and place the bid, but I'll come back to that. And actually, I can do this in order. We're going to place the bid. So this is where we actually place our bid, right? We have our data. This is the function that gets called of like, hey, we're going to place our bid. Let's look at the OEV sign data. And this is where it gets a little bit complicated, but I've extracted that already, right? This fetch OEV sign data is that import that I got from this OEV sign data. If you look at how API 3 handles their API, like the API data in the backend, it is actually quite complicated of how we get our values, how we get, everything done. 'Cause we're first party. We don't provide the data directly. We provide the data from like reputable sources like CoinGecko, CoinPaprika. They push that data on chain and we aggregate it, right? So we grab all of that information and we have something called this DAPI system. And when you look at each node operator, it looks like this. It's like all these different positions, and I'm going to do pretty print that has all these different air node systems that have certain signatures that validates where it came from and what their template ID to generate that price and the timestamp that gets updated. This is extremely complicated to understand and view. So what I did, it was just make a tool that converts that into what's the price going to be in 30 seconds, basically. So that's all I've done. And that's what this does. So this just basically does all the math, the hashing, all that stuff. You don't have to change any of that, right? Like I'm just going to the sign API 3 data. What is the air node? How many air nodes for this air price, like this price, blah, blah, blah. Give me the number at the end of it. And so that's exactly what I do. So you don't have to modify that, but we want to know what we're bidding on, right? We want to know what the bid price of what our ETH/USD is going to be in 30 seconds. So that's the update. So what do I mean by 30 seconds? There's actually a small delay of real-time price into what gets pushed on chain. So you theoretically have an option to look into the future for 30 seconds to see what the price is going to be. So if ETH is on a drop and in the next 30 seconds is going to drop on my liquidable positions, I'm going to bid, right? And so that's where I get these details from. And then I was going to say, hey, the target chain ID, what is my target chain? It's for Sonic. So I'm making sure that this is for Sonic. And then I'm going to go ahead and build my my object for the auction house. I'm going to find, hey, my sign data cutoff time. Can I bid in this 30 seconds? Do I have to wait a few seconds to bid? If so, what is my cutoff time? And it's basically looking at the length, right? And then I get my bid topic that we did up there, passing that data. And then I get the bid details, that same function that we did, right? I want to make sure that my OEV feed updater is the one that's going to be doing the update. And I just console log, right? I console log the topics, the details, current timestamp, letting me know that this is what I'm bidding on, right? Here's where we actually place the bid, right? We place the bid with an expiration. I want my bid to only last so long, right? And so it's going to have the bid topic that we've already done that we don't modify. What's the chain ID on there? We're using Sonic, right? How much am I going to bid? It's that 0.001s, all the bid details on here. My collateral basis points are all set to the max. The protocol basis fee are all set to the max because if I don't max them out, I don't win the bid, right? I have to pay the maximum amount I'm willing to bid. And then we don't have any fees on the auction bids as of yet. All that profit that goes into this, majority of that goes in back to the DAO, right? And then when I bid, I have 30 seconds to do this. So we know what the expiration time of this next bidding phase is going to be. And then we've placed that bid, right? And so now that we know what the bid is, we have to do our bid ID. So there's a little bit more encoding, right? Everything's encoding, decoding in Solidity all the time, right? That's basically what we do. So we're just making sure that, this is the wallet that we want to update it with. Here's our bid topic and here's the bid details. And we just basically encode, decode all this information on here. So that's what we do, our bid ID. And that's how we reference, like, how's our bid looking in the auction house, right? And so now we're listening to see if we've won, right? We're waiting for that bid to be awarded. So we have this little loop that's going to happen for the next few seconds, whether we bid it in the beginning of the 30 seconds or if we bid right at the 25-second mark. We're listening to see if we won anything, right? And so it'll just wait every 0.1 second and let us know if we won. If we did, then we got a bid awarded and we have that special signature that we can use to update the oracle, right? We got that allow list on there. And that's when we want to update our transaction, right? We want to perform our OEV updated with that awarded signature, right? With that signature that we got from there. And then we're making sure that we are within the cutoff range. And then we get all the price update details that we've had, on the bid, right? And that's in the perform OEV update. And that's, we don't change that at all. We just have all these structures and values on here and saying, hey, we're performing the Oracle update. It's going to pay bid and update the feed. And that's going to reference that, contract of pay bid and update feed. And we pass all those parameters that we have in here with our bid amount, right? And then we just wait, right? Contracts do its thing. It does its magic, goes back and forth with the callbacks, and it lets us know, hey, the Oracle update has been performed. Here's the transaction hash. And we're almost done. We did our Oracle, we did our liquidations, we did all that logic. But remember, we have to tell the OEV network, hey, we behaved, we updated the Oracle, we did what we were supposed to do. Don't slash me, right? And so we're just going to report that fulfillment. So we get that transaction and we go back to the OEV network. These are the objects and everything. And we just say, hey, we want to report to the auction house. We did it, right? This is our bid topic. This is the hash that we just came up with on this hash. And then here's the transaction hash, right? And then OEV network auction house is going to say, hey, yeah, you did what you did supposed to do. Thank you for doing business with us. You can keep your stash for another bid, right? And therefore, you're not locked up. If you want to withdraw from the OEV network, you absolutely can. And we just wait for that fulfillment to actually happen. So it sounds complicated, but all we're doing is say, hey, I want to place a bid. I know you don't speak English, so we have to encode and decode everything. Did I win the bid or not? And if I did, okay, I'm going to update the Oracle. I do it on the chain and say, okay, I did it. I'm reporting back to you. Don't slash me. And that's pretty much all what this script does. It's very, very simplistic on here, but that's it. Did I meet it within the 30 seconds? Here's all the encoding, decoding. I want to place my bid. Did I win? Cool. Let's update the Oracle. And then I reported it. And that's that, right? I know that's a lot to swallow. That's why I have this companion video. That's why I have this workshop for anybody that has questions. But whatever I bid, right, this bid amount, and I'm not, I'm bidding chum change here, but this bid, 80% of that goes back to the DApp that I updated.
Step by step, I think it's very clear. It's sort of like if you look at the whole thing together, yeah, it's complex. But like if you break the way you broke it down, I think function by function, step by step, it
Yeah.
makes it really, really clear to understand what's happening. It's super cool. Um, yeah, I mean, this has been again like super good for people to I think look back on as well in the future. I think also what I'm probably going to do after this is over is feed the entire workshop, all of them together into an LLM, and
Yeah.
then sort of see if we can generate some interesting stuff out of the workshops. Because actually, some of them actually can ingest video now as well. So
This is crazy. Yeah.
yeah, it'll be super cool. But yeah, no, I think this was like super informative for me once again. I'm definitely gonna test and try some of this stuff out myself
Yeah.
on the weekends. But
Well,
yeah,
let's
this
do this
is
live. I'm gonna do it live. I'm gonna actually bid this update right here. Let me see
oh sick.
what's the price of Sonic right now. So like 2499.55. That's what CoinGecko has for ETH right now. So this is like I'm a liquidator, I'm a searcher, so it's like 2508, right? So like 1% deviation, it's not going to update, but let's say I can liquidate someone around this range, right? It's not exact, but definitely going to change. So I'm going to bid, and we're going to go through the whole flow, and you can console log it here. So I'm going to go ahead and submit bid and update, and let's see what we get. And so I'm doing ETHUSD, and this is all the encoding. This is the next price in the future, 2509. On here is what I'm doing. This is the current timestamp. So I'm waiting for the bid to be awarded. I've already placed my bid. This all happens in seconds, right? I'm just waiting. Bid awarded. I won. I performed the Oracle update. Let's see. Boom. Oracle update has been performed. So this is where I do my liquidation, right? Everything looks good. I'm going to have to report back to the OEV network, and I'm just waiting for that confirmation to say, hey, I fulfilled it. Are we looking good, OEV network?
Are we
Boom, we've
billionaires
done it.
yet?
And that's it. It's all been confirmed and everything. This all happens in seconds. And if I go here, 2509, it has now been updated to the most exact price on here. I can run my liquidations, I can do everything. And that is powerful. Yeah. If I have the price, the ability to just pull the most updated price when it matters, that supersedes MEV, right? I can't, doesn't matter where I am in the block because I have the power to update the Oracle.
Yeah, and especially like sort of chaining stuff onto that update. I think super interesting to This sort of structure appears a lot in programming, where you have sort of like a one-two punch, where
Yeah,
something is a dependency on another thing. I think it's sort of, if you're a dev, you sort of understand how this sort of thing works. But
yeah.
yeah, I think it's super clear, super cool.
Yeah, yeah. I mean, this is probably the most complicated part of everything because it's fairly new. No one's really talking about it, but now every or other oracle's kind of playing catch up in a sense. But yeah, I mean, again, and then once I do that liquidated, remember whatever I was willing to pay to do this, the opportunity to do this. I mean, we're paying, people are paying up to like hundreds of thousands of dollars to make this happen. So you can choose any oracle, like they're all great, they all provide a service, but by just switching your Oracle to API 3 and having OEV enabled, you now have additional options of revenue, right? Like that simple. That's why we call it
I've
API
said
3.
this before. I've said
Yeah,
this before, but it's so interesting that like API 3 has such a similar I guess value prop with respect to other oracles that Sonic has as a layer one with
yeah,
with our FEM program, which is literally just like take your contracts and deploy on Sonic, and you just
yeah,
get extra revenue with the fee monetization because you're earning 90% of your gas back. So it's
yeah,
like super interesting that like the parallels there, and
yeah,
yeah, kudos
definitely.
to you guys for innovating on the economic model there.
Yeah, definitely. I mean, we have a dashboard so you can actually see how much money each one that has been converting over to it. So stability at Stonic has now just switched over. So you can see exactly all the liquidations that has happened, how much money they've generated, how many OEV liquidations happened versus how many MEV liquidations happened. And you can see that we OEV beats MEV like 99% of the time on Sonic. So whether you're an MEVer or OEVer, right? That's basically what happened. They just launched, so it's pretty low, but you can see that OEV is dominant for liquidations on the borrow lending platform.
Yeah,
So like anybody trying to
yeah,
do regular liquidations on stability will lose. So yeah,
yeah. That's
yeah,
powerful. Amazing.
yeah, yeah. So yeah, yeah, that's OEV in a nutshell. I know that's a lot to swallow. I know it's a lot to take in, and so that's why I kind of space the workshops a little bit so people can kind of digest, ask questions. Maybe more details on the script because I go through it a little bit quick. But now you have the GitHub repo that you can go side by side. You have a video companion on there. But yeah, it's a lot to swallow. But if you, as a searcher, take advantage and win the bid, you don't have to stress out on like MEV botting, right? Like, or getting wrecked on that. This is like OEV, like MEV on training wheels for liquidations, right? You're not going to get wrecked on there. You just win the bid or you don't. And if you win the bid, you have 30 seconds to take your time to win. So, yeah,
Amazing.
yeah.
Cool. I think let's sort of start wrapping it up here. I think this is really cool. Is this two, and this is two of four sessions that you have
Well,
planned?
no, the next few sessions kind of get broken up. Like three has a 3A, B, and C to it. Because
Okay.
first thing we're going to do is deploy Aave, and that's going to take the whole hour just deploying it. Then we're actually going to set up a liquidation setup, learn a little bit more about borrow lending, why people do it. And then the third one is we're actually going to do it with a little bit of OEV in the mix. So, like, actually updating the Oracle and then doing it. And then the fourth one is going to kind of be like just flash loans using Tenderly and a few other tools just to understand it. And then the last part is where we put it all together, OEV, flash loan, update, liquidate, everything all in one single package.
Okay. That's Sorry, I was just switching the
Yeah.
mode.
No.
That sounds super exciting. I hope that we're able to continue this on a weekly cadence, and if not, then it'll be sort of in between other appearances. But I think that this is good info. It's important info. You deliver it super well. I think it's super engaging for me at least, and I'm sure all of the other builders that are watching this feel the same way. And yeah, as I mentioned, it'll be good for archival, and I think this episode was super interesting, and it exposed a lot of concepts that I think will be valuable to people. So, yeah, thanks so much. And were you was that your conclusion? Did you want to discuss anything else before we end off here?
No, no, no. This is it. I threw it all in there. I'm waiting for people to actually digest it a little bit more. This is probably the most complicated, nuanced kind of concept to kind of absorb on there. So yeah, I'm pretty sure in the future you'll start hearing more and more panels about OEV or whatever they call it. But in the end of the day, it's Oracle extractable value.
Yeah. Yeah, you guys
Yeah.
are, I mean, innovating on the economic model of oracles, whereas like we're innovating on the economic model of L1s. Like,
Yep.
I think it's important to just in your respective field sort of push things forward, and I think you guys are doing that. And yeah, super happy to have you guys on Sonic. And I think so. We'll coordinate when the next one is, and then we'll give everybody that's watching a heads up if you're interested to continue watching the sessions with Billy. And that concludes our episode 6 of Sonic Builders Hour. Once again, for those who aren't aware, we do this as many weeks on Friday as possible. And the idea is to spotlight our builders and our infrastructure partners so that they can sort of expose their products to other people who may not know about them, and then also sort of explain how to interoperate different things on the Sonic network with different protocols and that kind of thing. So sort of trying to breed some more sort of interoperability and teamwork between our apps and our platforms. And Billy's explaining to our builders today on the second time he's been on with his workshop, basically how to use OEV with API 3 and just exposing some really interesting concepts for us today. So looking forward to having you on for future sessions, Billy, and completing this multi-part series with API 3 and OEV and all these interesting things. And hope to see you on the next one, and hope to see you all on the next one as well.
For sure. Sure. Thanks for having me, guys.
Thanks,
Hopefully
Billy.
soon.
Soon. See
Yeah.
ya.